All right, next example, we have two matrices, A and B. The first one is a square matrix, 3 by 3, and the second one is a general matrix, a 3 by 4. And we want to compute, if possible, A times B and then B times A. So the first thing you should always do is make this little dimensional analysis. So for product, so A is a 3 by 3. So I like to write the dimensions on top. So we have a 3 by 3 and B is a 3 by 4. So we see that these two numbers, the inner numbers, they are equal, so they match. So we know there is a product, and we even know the dimension, which is equal to the outside number. So it's going to be a 3 by 4. So again here, I'm just using the outside numbers. So here 3 and 4. So this is how I get my 3 by 4. So AB is defined. It's going to be a 3 by 4. But meanwhile, if you flip them, so if you look at the dimension of B, so it's a 3 by 4 multiplying a 3 by 3. But now when you look at the inner numbers, the 4 and the 3, so they're not the same. So this one will be undefined. So the only one we have to care about is computing the product between A and B. All right, so let's multiply A and B. The first thing you do is you rewrite A and B next to each other. And what I like to do, the way I like to do multiplication is I like to circle the rows of the left matrix. So in this case, the matrix A. So here I'm going to use a marker. So my first row is 1, minus 1, 3. My second row is minus 4, 5, and 7. And my last row is 3, 6, and 9. And then, so I see here, I have 3 rows, and these rows, I can think of them as vectors, and all these vectors, they have 3 components. And the way I like to compute the product is really using, is going column by column of the right matrix, in this case, B. So I'm going to start with the first column of B, which is 2, minus 3, and 2. And what I'm going to do is I'm going to take, and you can see here this column, 3 entries. I'm going to compute the dot product between this column and every single row. So my first entry, so on row 1, column 1. So if I take 2, minus 3, and 2, so my first column, and I do the dot product with the first row, you get 2. So let me write the details. Again here, you could just compute it, but if you want to see the details, I'll do the detail for the first column, but then I'll just compute it for the next one. So you get 1 times 2, so I'm doing the dot product, plus minus 1 times minus 3 plus 3 times 2. So that's my first entry. So on the first row, first column, then I use the same column, but now I'm going to do the dot product with the second row to get the second row entry. So here, minus 4 will multiply 2 plus 5 times minus 3 plus minus 7 times 2. That's going to be on my second row. And now for the last row, the third row, what I'm going to do is I'm going to do the dot product with row 3 and still first column. So I'm using the first column to compute the first column of my result. So you're going to get 3 times 2 plus 6 times minus 3 plus 9 times 2. So I'm doing the dot product here. That's my first column. So if I use this color scheme here, so you can see where my first column was used. So I have my 2 minus 3, 2. That's my first column. And it was used on every single row. And then if you look at where the rows were used, so if I go back to green, so you see my first row, 1, minus 1, 3. My second row was minus 4, 5, and minus 7. And my last row was 3, 6, and 9. And then I do the actual computation. So if you do the dot product Okay, you're going, like if you just multiply and add, you're going to get 11 for the first entry. You're going to get minus 37 for the second entry, talking about the first column here, and then the last column, the last row will be 6. So that's my first column computation. Now if I move on to my second column, so same idea. Okay, so you're using now the second column, and you're going to do dot product with the second column, with the first row, second row, and third row to get the entries of your answer in the second column, first row, second row, and third row, respectively. So let's do it all since we have nothing else to do and our lives are just super boring at home. So here we have 1 times 2 plus minus 1 times 1 plus 3 times minus 4. So, and then we continue. So here for a second row, so I'm taking the second row of A, so you're going to get minus 4 times 2 plus 5 times 1 plus minus 7 times minus 4. And then the second row, doing the dot product with the second column, using the dot product with the third row, you're going to get 3 times 2 plus 6 times 1 plus 9 times minus 4. And if you do the actual computation, you're going to get minus 11, 25, and 24. If you want to see some color here again, just to really feel it, maybe use a second layer of colors just so that we can see it. So you can see the second column, 2, 2, 2, 1, 1, 1, minus 4, minus 4, minus 4. Let's use 2 colors since it's the second column here, so darker. And then my first row was here, 1, minus 1, 3. Then my second row, minus 4, 5, minus 7. Actually, let's use second layer of colors for a second row. It's a bit subtle here, but so that we can see some distinction, so it's slightly greener. And then same thing for a third row. So we use 3, 6, and 9. So 3, 6, and 9. Let's do like a super bright green here for the third layer of green. Now let's compute the third column. Again, now it's really rinse and repeat. So you're taking the third column, so the 2, minus 5, and 5. Let me just change color. So the 2, minus 5, and 5. I'm going to use a triple orange here for a third column. So, and I'm going to just lay down that column. So here we go. So for first row, using the first row here, so 1 times 2 plus minus 1 times minus 5 plus 3 times 5. And then I'm taking the row, dot product with the second. So sorry, I'm taking the third column, I'm using the second row, so here we go. So you get minus 4 times 2 plus 5 times minus 5 plus minus 7 times 5. And finally, for the last row, the third row, so you're going to get 3 times 2 plus 6 times minus 5 plus 9 times 5. So if I use my color scheme here, I'm using my third column. So you see here the 2 minus 5, 5, the 2 minus 5, 5, and the 2 minus 5, 5. I'm doing it 3 times. No, wait, I don't know how many layers I did. Just a second. You won't see what's going on here anyways. Okay. Then where did I use my rows? So first row, 1, minus 1, 3. Second row, minus 4, 5, and minus 7. And then the last row, 3, 6, and 9. And now if you actually do the computation, you're going to get 22 minus 68 and 21. So finally, last column here. So minus 1, 2, minus 2. So I'm going to use 4 layers of orange here, so to make the distinction between all the columns. So here we go. So we're taking that 4th column and we're doing the dot product with the first row, second row, and then 3rd row. So here we go. So I have 1 times minus 1 plus minus 1 times 2 plus 3 times minus 2. So that's the dot product, row 1 with column 4. And we continue. So now we have with the second row, so minus 4 times minus 1 plus 5 times minus 5 plus minus 7 times 5. So that's the dot product between row 2 and column 4. And then finally, the dot product between row 3 and column 4. We have 3 times minus 1 plus 6 times 2 and plus 9 times minus 2. I just saw a typo there. That minus 5 on the second row. Just wait. So this is supposed to be 2, sorry. So there we go, 2. Yeah, sorry, I said minus 5, but I was looking at my previous computation, so that ends it up. So again, using my color scheme, where did I use my 4th column? So minus 1, the 2, and the minus 2. And then my rows, so my first row, I had my 1, minus 1, 3. My second row, minus 4, 5, minus 7. And then my last row, 3rd row, so the 3, 6, and then 9. And now if you do the actual computation, the final column is minus 9, 28, and minus 9 again. And that's your final answer. Yay! I just want to comment again here on the fact that this product is highly non-commutative, that if you are, so here's a remark, if you are computing AB, you're getting a nice 3x4 matrix with real entries, but if you're computing BA, that one was undefined. So you can see that AB is clearly not equal to BA. Okay, so fat remark here. Okay. Of course, we've seen a lot of examples like this already, where in one direction it works, but in the other direction it doesn't work. But this will lead to my final remark of that section, that even if they are defined, and even if they get to the same dimension, product is not going to be, AB is not going to be equal to BA in general. So we end the section with that remark again. So going over it quickly is that even if A, B, and B are defined, and even if they have the same dimension, we rarely get that AB is equal to BA. So in general, they're not going to be equal. So in general, matrix multiplication is highly non-commutative. And let's just do this with an example. So example here, 11.5.6. We have two matrices, A and B. Let's compute AB and BA, and let's compare. Of course, a punchline, very easy to predict, is that they're not going to be equal. So let's start with AB. So A is 1, 3, minus 1, 2. And we're multiplying with B, 2, 1, minus 2, 1. So the first row, so I like to always circle the rows of the left matrix. So in this case, A, so 1, 3, minus 1, 2. And then the columns of the right matrix, so 2, minus 2, and 1, 1. And now let's do the dot product. So the first, I like to do it column-wise. So taking the first column down to row 1 and row 2 using the dot product. So 2 times 1 plus 2, 3 times minus 2, that's minus 4. And then 2 times minus 1 plus minus 2 times 2, that's minus 6. And then the 1, 1, so the second column going down. So 1 plus 3, that's 4. And then 1 minus 1 plus 2, that's a 1. So that's the product AB. So now let's do BA, not the same thing. So you have to rewrite them. So 2, 1, minus 2, 1. And you're multiplying with A, 1, 3, minus 1, 2. So if you like to do the columns of the right matrix and the rows of the left matrix, so you're going to get the following thing. So doing the dot product, first column falling down, so you're going to do the dot product between 2, 1 and 1 minus 1. So you're going to get 2 minus 1, that gives you a 1. And then you're going to get minus, so if I'm doing the first column with the second row now, so minus 2, minus 1, so you're getting minus 3. And then now I'm moving on to the second column, so you're going to get 6 plus 2, which is 8. And then finally, you're going to get minus 6 plus 2, which is minus 4. As you can see here, these two things, these two matrices, so AB and BA, they're not equal. Okay, so matrix multiplication, AB or BA, even if they have the same size, in this case 2 by 2 matrices, not equal. Okay, so if you're asked to compute AB and then same question BA, you cannot just rewrite the same shit. You have to redo it.